Oh, this is again, I'm a singer, eternal voice. Let's talk about some a very special topic. Not really that special, but this is common in general chemistry lecture. But what I'm trying to say, topics that are not mostly well explained most of the times in general chemistry lecture. Okay, this is all about ionization energy. Okay, so it's gonna be ionization and lots of ionization energy. Okay, in terms of let's say calorie, something like that. Because the units are calorie or joules, like that, because it is energy. Okay, it depends on what is being there, the units, but of course, normally the units are in terms of energy. What are those? Calorie, joules, British thermal unit, the watts, something like that, and a whole lot more, right? And then, guys, I forgot to tell you that, for example, if, let's have conversion first, now of the units of energy, because we're talking about energy also. Okay? So each element has its own ionization energy with respect to if it will undergo reduction, oxidation, something like that. Will it have to release electrons or to accept electrons, something like that. Okay, so I have a very important conversion that we need to, to remember. So for example, if I have 1 calorie is equal to 4.184 joules. Okay, Joules. And times the Newton, right? The meter, okay? Like this. Kilogram meter per second squared times meter is the joules, right? Because this is Newton meter. And then this Newton is kilogram meter per second squared. Okay? So basically, joules is just equal to kilogram meter squared second squared, something like that. If you try to break down the units of joules, we can come up to the simplified unit, which is kilogram meter squared per second squared. Okay, because Newton is equal to kilogram meter second squared times meter, because we can derive this to the, force, work equals to force times distance. Okay? Like that. Because the unit of work is always joules, calories, something like that, or in terms of energy, of course. Okay? Like that. Anyway, you can convert joules to calorie, calorie to watts, watts to horsepower, if we speak about electrical energy also. If you try to correlate with electricity, it's easy to convert. That's why I'm gonna introduce to you the conversion factors for this. So 1 calorie is equals to 4.184 joules. Okay, mga palangga. Then I tell you one story about this. Okay, for example, if you buy food products in Bacala, in the market, in the malls, you are very clever to watch for the nutritional facts. So it's been presented there, the nutritional facts of, let's say, what do you call this one? The acids, how many, for example, acids, bases, like that, the sugars, the no added sugar, something like that, the cholesterol level, what else? So many, right? It's mentioned there the unsaturated fats, the saturated fats, the trans fats, okay, like that. So if you can notice, guys, there are calories given immediately, total calories, something like that. Take note also the form or the font FONT. Font. If you have the computer and you have the keypad, there's you go to the format cells, you double click right in the mouse, there's a format cells and it will appear the font, something like that. Okay, font, FONT, meaning the size of your letters. Okay, so there will be a difference between the capital C and the small letter C if we mean about calorie. Be careful. Okay, 1 calorie with capital C, small letter A, small letter L will not be the same as 1 calorie, small letters all. So this is also the gray area that most students did not discover yet. Okay? You get the point. This will not be discussed also most of the times in our instructors in our college days, unless you are very, you are very smart enough to research by yourself and try to research all the conversion factors, maximize all the conversion factors because you're an engineering student. But not all that don't have that attitude. Okay? Not all. Okay? So it's up to the students who have very, very wide, critical thinking and, initiative out from the classroom instructions. They still have to study to add more knowledge apart from the knowledge that their instructors deliver to them. Okay, but there are only few like that. For example, out of 10 students, only two, the statistics. Okay, because normally they study because they want to pass the subjects only. Okay, to have good grades and to pass because their parents are paying the tuition fee. That's all. They need to graduate, they need to pass only, but deeper purpose don't have that. Okay, don't have the deeper purpose because the deeper purpose is to learn something to apply that in your day-to-day life and in the future. That is the deep purpose why you study those subjects. To learn by heart seriously so that you can apply that in the real world in order to survive to this world, and you can apply that in the reality if you are landing a job in the future. So this is the major purpose why you study different subjects to learn, not only to pass subjects or to graduate. Okay? You get the point? If you have that ability and culture, then you have to expand your knowledge apart from your classroom instruction. You go to other topics which is more advanced, something like that your instructors are delivering in her lesson plan, something like that. You need to go extra, something like that. Okay? So this is not mentioned very well. The 1 calorie and 1 calorie is not the same. Okay? The big capital C, small letter A, small letter L, and the small letter C, A, L is not the same value. Okay, in physics and chemistry, the 4.184 joules is the small letter CAL calorie. It's not the big C. If you have the big capital C, one capital CAL is equal to 1,000 calories. So there's a very big difference now. Take note only with the font, big letter and the capital letter, it matters a lot now when you compute. You get the point? If I will say, how many calories of 78.7 British thermal unit, or how many calories is 786 horsepower? Then convert that to calories. And if I will write big C in my terms in the examination, it's not the the usual calorie we mean in our college days or in our high school days. It's totally different. This is now 1 capital C, small letter A, small letter L calorie is 1,000 small letter calorie, CALOR. So imagine, because this kind of conversion is dealing with more in clinical science and medicines. Okay? Not really in the other parts of profession. So it's not also being catered there. But actually, if you try to research, you will go outside from the box. Aside from the classroom, there is also another unit that is not mainly or commonly discussed in our curriculum, in our engineering curriculum. Maybe others already know also, I am just only late, but based on my experience, this is the first time I learned this definition or conversion factor. 1 calorie, 1 capital CALORA calorie is not the same with the all small letters calorie. So just like in 1 liter, 1 liter is equal to 1,000 milliliters. Okay, so the letter there are capital L, Liter, or small letter. It's okay, but what I mean, 1 calorie is also 1,000 calorie. Okay, it matters a lot. You get the point? If your equations have a heat energy unit of capital C written in the book, be careful because it is not the usual calorie we refer to, which is 4.184 joules. Things like this matters a lot in facing examinations in the future. You get the point? Like that. So take note. Ganon. Now go back to the ionization energy. I relate that because we are dealing with energy. So energy is the capacity to do work. Energy is the ability to do work. Ganun. Okay. So meaning to say, you always have the energy, then you have to apply force. At the same time, you cover the distance. with a vertical distance or a horizontal distance. And of course, you are moving, not stagnant. You are not static. You are moving. You are in dynamic movement or emotion when you do the work. Okay? That's energy. Get the point? So every anatomy structures are always moving when you do the energy. Okay, your vital organs, your mouth, your feet, like that, your muscles, your neurons, your hormones, everything you are moving when you do the work. Okay, especially the brain. Okay, because it dictates everything, your vital organs, the communication process. Okay, it relates to your hormones, something like that. So you need to do it, perform the work by just having that kind of concept. Okay, something like that. Now going back to ionization energy, so we know already a little bit of energy, right? I explained to you the unit and explained also the definition of energy, right? Now we go to the ionization. What do you mean by ionization ng mga palangga? Okay, so ionization is a process. Okay, when you see letters I O N in the last term, that is more talking about a process. For example, crystallization, distillation, centrifugation, okay, chun, mga ganon. Okay, what else? So many things. Okay, filtration, flocculation, sedimentation. Okay, a lot. Okay, dilution, concentration, evaporation, vaporization, condensation, sublimation, diba? Neutralization, polymerization, okay, sublimation. All those terminologies that ends in ION are all processes, okay, or operations like that. So this is already having an action verb. Okay, action verb. When you ionize something, then there's an action verb. What is being put into action are the ionic compound. Okay, ionic compound. Okay, again and again and again, a trillion of times, I will explain this. Ionic compound is a combination of metals plus non-metals. Okay, like that. And then metals plus gases or metals plus polyatomic and ion. Okay? Because polyatomic and ions are also non-metals, but not gases. Okay? Because I said in my general formulation of ionic compound that states that metals plus non-metals. Non-metals are not only limiting to gases, also polyatomic and ions. For example, sulfates, phosphates, silicates, dichromates, manganate, permanganate. There's a lot, right? Bromate, iodate, hypochlorite, something like that. So those are polyatomic ions with negative ions charges. Okay. So, pwede na mo siya, it's okay to add that to the metals to produce the ionic compound. It will never become an ionic compound, mga palangga, if there's no polarity, meaning opposite charges. Okay, that's one thing you build in your brain cells or accumulate in your brain cells. It could never be an ionic compound if the charges are not opposite or not in polarity. Okay, something like that. There's no polarization of the charges. Opposite charge, positive and negative, anion and cation. Okay, yun ang point mga palangga na yun. Okay, now that's ionization. And now, if that energy is in process for this particular ionic compound to produce individual ions, it's called ionization energy. Okay, meaning to say, the energy here are coming from the ionic compounds during the process or during the operations or during the chemical reactions when by the time when the ionic compound will dissociate, splits off, okay, and converted to various elemental constituents coming from your ionic compound. Something like that. Okay? It's very enjoyable, right? Now, there's another technical definition because I'm introducing to you a while ago a general definition that will also be logical, but we need to go deeper technical, something like that. So, in a way, if you understand something, if that is also general, that would be also okay. But there are also times that technicalities are more, are more precise to consider, especially if you relate now with atomic structures, how they will be oriented in your atomic orbitals, like in dissociation, chemical reaction, in your geometrical, symmetrical, chemical orientation, well, chemical bonding, ganon. Okay, now, ionization energy, of course, lalo na kayo siya, is an energy required. Okay, if you want to memorize immediately, then put in your brain cells. If you want to put in the paper, then put also on the paper and then later memorize. Then understand first. Okay, ionization energy is an energy required. Okay, okay mga palangga, to remove an electron. Okay, to remove an electron. Okay, from a gaseous atom. Wow, nakakaloka. Gaseous atom, something like that. Okay, this is only generic gaseous, but it's not limited to gaseous. As long as it will exhibit ionic property. Okay, that's only the parent definition, but it is not literal and limiting only to gaseous. Get the point? You get the point, mga palangga? That's it, ionization energy. Now, I will show you how we can connect this to the periodic table or the periodic trend, because most of the, concepts and theories examination in the word examination is more about on the how you would relate this in the, in the periodic table, the arrangement of these elements in the periodic table, the 118 elements, right? Something like that. Okay, now, nakakaloka. Diba, mga palangga? Okay. So, ganon. Okay, ionization energy. So, if we have the periodic table, let's say, we will just imagine, because I cannot memorize everything, something like this. Okay, ganon siya. Okay, like that. Now, and then there are also two rows, the actinide series and the lanthanide series. Okay, something like that. And then we'll be able to say, this part on the left part is more on the metals. As you go over to the left, that is non-metals. Okay? Like this. And of course, arrange in an increasing atomic number from left to the right. Atomic number N, AN, or the protons. Okay. Like that. This is also a great part, mga palangga, no? Because, in the topic of the electronic configuration, remember, in the topic of the electronic configuration, you are referring to the atomic number, and that is the proton. Then why you use that in your electronic configuration? It's supposed to be you will use the electrons. Why? Why? Because that is in natural state as a proton. It will just become an electron when it will react or when it lose and give to other metals or non-metals. You get the point? Maybe you're confused. There's a little bit of gray lang siya, but if you try to deeply explain, you can explain that. Okay, for example, atomic number is the same as number of proton. Okay. Now in chemistry, if we can remember our stock knowledge, if we deal with isotopes, okay, elements that have the same atomic number or the same number of protons but differ in their mass numbers, those are isotopes, right? Then we speak about atomic number, that is a proton, it never be an electron. Then why the electronic configuration, we will use the atomic number in the arrangement, in the orbital. Okay? That would mean if it will only be activated, it will become an electron. For example, ako si Junjun. When I lose my electrons, then that will become now an electronic configuration. Naturally, there are protons in me. And then the protons will be converted to electrons when I give this proton to others. Like that. You get the point? So basically, my protons and electrons will just be the same, normally. And then, in the process, this is not now a proton. This is now already an electron because it undergo actions or process or operation. You will never say now proton configuration. Instead, use electronic configuration because you are dealing now with the orientation of the movement of electrons, whether it is being shared or not, something like that. Then you can never say proton already. But the behavior naturally at first will be tantamount with each other. Tantamount meaning symmetrical or similar. Something like that. You get the point? Ganon. Kasi nilibog mo sa proton o sa electron. Okay? Remember also another great part also, the electron is in the outermost shell. because it is lighter than protons and the neutrons. Protons and the neutrons are inside the nucleus, right? As an electronic particle is the same as an electron. But electron is very light gas. It has a mass of 9.109 times 10 to the negative 31 kilogram. Whereas these protons and neutrons have masses of 1.67 something, which is the power negative 27 kilogram lang siya. So it's understood that the protons and neutrons will be chemically bonded with each other inside the nucleus. And what happened? These electrons will be revolving in the outermost shell in each energy level or the shell. Okay? So why these electrons will have the same characteristic in protons in the electronic configuration topic? That's only a little bit of, a little bit of confusion in which the students must understand really. Because that is basic foundation. Okay? Mas meaning mo proton configuration. It's not proton configuration, but electronic configuration. It's just happening that the proton will be losing to and will become electron when it become lost. That's why loss of electrons. It's not the proton will be lost, but the electron. But naturally, proton and electron will just be the same in that atom. Kung wala pa yung nahitabo. Ganon. O diba? That's why most metals are electropositive. Imagine electropositive, meaning positive electrons. Oh my gosh, pero there are positive electrons? Yes, there are positive electrons. Okay, and that is positrons. Wow, positrons. You get the point? Mga palangga. Okay, so kusubunan na ito ang idea na only negative electrons. There are also positive electrons known as positrons, or the protons of each element naturally when not activated yet. Okay, that's also your electron. Okay, that's why we have reduction and oxidation process. Okay, mulos mag-electrons. Itong electrons, proton, basta na ito sa aluminum, sa like, hindi ko makalimut siya sa pero ato na lang yung tukion para, di ba? You know the point. Okay, ganon. Now, if I have the atomic number increasing from left to right, and have also the atomic number is increasing from top to bottom in each group, okay, something like that. Tama also in saying, from left to right, your atomic size of your element is increasing. Remember, every word came out in my mouth, remember. Okay? Atomic number increasing from left to right. Okay? And also top to bottom in a group. And also the atomic size. Atomic size, atomic radius, atomic radii of each element also will increase from left to right. And also from top to bottom, okay, you will also increase your atomic size, atomic radii, atomic radius of your element. Okay, so it's now easy for us to determine in a question in the future which of the following has a bigger size. A, chlorine, fluorine, bromine, iodine, astatine. So you can determine already because that is in a period from top to bottom, it is increasing. Okay, things like this. Okay, you get the point? Oh, mga palangga. Okay. Now, how can you connect the ionization energy here? Okay. How can you connect your ionization energy here? So if you try to correlate the size of an element or the atomic size of an element, for example, if the element is going downward in a group, okay, something like that, what will happen to your ionization energy? Okay, something like that. Okay, what will happen? Ano, mga palangga, kasi matago mo. Ganon. Makakaloka. Diba? So, guys, opposite siya. Okay, we have an opposite relationship. So, if the atomic size of your element, as it goes downward in a group, in a periodic table, your ionization energy will increase. Something like, parang ganon. And then, from left to right, something like that also, what will happen for that? Okay, what will happen for that? Still, it will be increasing. Okay, like this. Go from left to right. Why? Why, mga palangga? Okay, as it becomes non-metals, okay, the electronegativity will increase. And the electronegativity is having a direct proportionality with ionization energy. Okay, that's why it will go from left to right, it will increase also, the same as electronegativity. The more the metals will be going to the right, yes, the right, it will become non-metallic. Okay, so if it will become non-metallic, the electronegativity will increase. Also, the ionization energy will increase. Okay, that's why, that's the correlation. Okay, now, nakakaloka. Now, what will be happening of your boiling point and melting point? Okay, ala naman siya pero guys, sa mga elements gani, mga substances, atong itisok sa atong galamhan or alimpatakan na it's always considering the melting point, boiling point, freezing point. These are the common physical properties to be explained, okay, by the instructors because it happens naturally in our day-to-day lives. When we heat the water, when we cook the food, we can observe this in our eyes, in our very, very big eyes, how it become boiled, something like that. The water is boiled at 100 degrees Celsius, and I have to boil this, kabush. Boil the kabush or heat this kabush. Well, you can observe really, oh, it's very hot now, and then you stop the heater. So it's in our daily lives, these things. So we need to correlate these things to boiling point and melting point. Okay? You get the point, especially burning, when you burn something. Okay? And normally burning is also very common in our day-to-day life. When we cook the food without heater, without electrical appliance, then we can cook the food by just having the wood as our fuel. Yung magbuyok din tagtanon or bugas, ana. So, very common yun ang mga boiling point, heating, burning, melting point. That's why we need to correlate that in our periodic table. Okay, something like that, the basics. Okay, now what will happen to your melting point and boiling point if from left to right? O, di ba, nakakaloka? What will be happening? Okay, so, it will be now, the melting point will be now, okay, decreasing. Okay, like that, from the top to the bottom. So we need to say, there is a higher melting point and boiling point from the top in a group. Okay, that's the point. Something like that, mga palangga. What will happen in your horizontal, in predictable, the family, or the period? Okay, the horizontal rows represents the period or family. In the periodic table, the vertical represents the group. Okay, like that. So what will happen? Okay, now, it will increase. Why? Why it will increase? Because in your ionic properties, mga palangga, okay, that is very light already. Light. So, meaning to say, it doesn't have the conductivity na talaga siya. Okay? Metals are highly conductive to electricity. Non-metals are not conductive to electricity. Now, relate that with your thermal conductivity. Thermal. Okay, thermal conductivity. The word thermal is also heat. When you boil something, you involve heat. Right? When you melt something, you also involve heat, in which at higher temperature. So now you can correlate that understanding there. You get the point? So if you try to have a higher thermal conductivity from the right, okay, meaning to say, you are decreasing your melting point and boiling point. So it needs to have a higher melting point from left to right. Something like that. Okay? You get the point? You get the point, mga palangga. Muna siya mahitabo. Okay? Dugay siya ng melt, guys. Or kung, o diba? Okay. Atong balikod ka mahitahin mo na. Charot. Okay. Ganon. Guys. Diba? If we speak about, let's connect a little bit with English, ha? Kahit sila we can really learn the terminology. For example, I will say atomic radii. Radii. So, anong radii? Radii. R-A-D-I-I. Okay? Then there's also radius. Now, where is the diameter? Okay, how can you connect the diameter in this terminology? Okay, diameter. So normally, if you try to consider the pipeline, there's also a technique inside thickness and outside thickness, cross-sectional, something like that in your, for example, schedule 30, schedule 40 your pipeline, then you have to compute, right? Especially in the topic of transport phenomena in fluid flow, fluid mechanics, fluid dynamics, then you have to deal, especially in connection with the thermodynamics, something like that, guys, or heat transfer. You still remember that one? You need to determine, especially also the thermal radiation through convection. Yung mga radiation na, you need to determine the inside thickness, outside thickness, ganun-ganun. Di ba you could still remember that one? Okay, and you need to have the thermal resistance, ganun ganon. Okay, na ang unit na yato kay watts per meter squared Kelvin. Okay, unit of your thermal coefficient. Okay? You get the point? Gamiton din mo sa mga insulation. Okay? If you try to insulate this wall with a thickness of something chuba-chuchu in a flat layer or even a pipeline, a diameter of the pipeline. You remember that one? Schedule 40, ganon. Okay. Now, from the diameter, we have also inside diameter, outside diameter, ganon. And there's a lot of table for that in our handbook, chemical engineer's handbook. Now, or mechanical, or whatever engineering you are taking, something like that. Okay. So diameter, ano siya. Then, Sir Sotero, what is radii? Okay? Radii, di ba? Nakakaloka ang radii. Now, if you try, if you try to connect that with the singular and plural form, if you say fungi, living microorganisms, okay? Fungi. We have also fungus, right? Like this. Alumni, alumnus in English, right? So these are singularity, plurality, something like that. So since this is katunog or rhyme with radii and fungi, so this is singular of the diameter. So meaning to say, radii and radius, it's the same meaning. Because radius is the half of the diameter. Okay? So meaning to say, atomic radius and atomic radii is just the same story. Because radii and radius is having the same definition. So don't be confused if we will use radii now in our computation, in atomic orbitals. Because this radii thing is more on the electronic configuration, it relates to the chemistry. It's not used most of the times in the, in the fluid flow. They will take the word radius there. Most of the time, radius and diameter. But we don't know really also if they will try to mix the radii there. Right? 24 radii centimeter, and you will be confused because you did not meet this kind of word. Okay? So problem also, you need to research, and there's no dictionary there in the actual examination. You are not allowed to open the data in the actual examination or Google search, something like that. And the books also, it's very difficult to search that also in the table of contents. It will take a lot of time for you. So it's better you have that stock knowledge retained in your brain cells. The radii is just also the same as radius. Agree? Oh, that's it. Okay. Now, the atomic radii or the atomic radius will also increase the same as with your atomic number from left to right in your periodic table and from top to bottom of your group in periodic table. Okay, klaro kaya siya. So atomic size that we are referring to, because radius, it represents the size. Okay, you get the point. The size of an atomic element is the radii and the radius. Okay, wala na siya naitago guys. Okay, now, if I have to relate this in a periodic table, okay, ganon. Okay, just remember guys ha, okay. Hala mga palangga, ano? Next month is the chemical engineers board examination pala. Okay, by the PRC, Philippine Regulation Commission. Oh my gosh! Okay, na-remember na ako akong time na I took the chemical engineers board examination. Oh my gosh! Really, buwis buhay. Okay, now, going back, next month na pala guys. Okay, get the point, mga chemical engineering graduated students in, chemical engineering students in nationwide in the Philippines only, especially the CIT University and the University of San Carlos in Cebu, because there are only 2 schools offering chemical engineering in the entire Cebu. Okay, something like that. Okay, we have the periodic table. Okay, now, okay, if we speak about ionization energy, something like that, and I could say, mga palangga na, the arrow will go to the top, increasing ionization energy, and then left to right also increasing ionization energy, and then diagonal also increasing ionization energy. Now, if you talk about ionization energy, electronegativity, electron affinity meaning you get to combine the electrons Because affinity in dictionary is combination, addition, union. Okay? Then if you try to put that in a chemistry point of view, okay, the ions are being unified or united or combined or added with each other or compacted with each other or bonded with each other. That is electron affinity. Oh, ganon. You get the point? If, for example, if the solid, or no, if one liquid is not in affinity with the other liquid, so this kind of liquid is immiscible. So meaning to say, liquid substances are based on the affinity, okay, how they chemically combine through its solubility, something like that. Solubility, how it dissolves completely or not. Meaning to say, if it is not dissolved, the technical term there is immiscible. Immiscible. Immiscibility or immiscible, meaning the liquids are not soluble with other liquid. Okay. Now, it is also the same as insoluble. Okay. But the only difference, immiscibility and immiscible, it is specifically referring to liquids. Okay. You cannot apply easily that to solid and liquid. So you will take the chemistry grammar in using also. You get the point? Because if you speak in, you say, this, alcohol is immiscible with pentane, something like that. Okay, because you're referring to liquid. But now in your discussion as an instructor, you will say, okay, sodium chloride is immiscible with alcohol. You will never use that because immiscibility is applicable only to liquid. You have to be careful also in every technical terms that will come out in your math during your discussion. Because there are also students who are very clever to, to differentiate, to distinguish what the difference, this term over the other, especially also engineering students who are good in English. Because not all engineering students are not good in English, though so many are not good in English, but there are also engineering students who are good in English, but admittedly, only few. Okay, most of the engineers cannot deliver fluently. Okay, but there are still some, or there are still few, but not so many. Okay, they are loving with numbers, and they talk straightforward. Okay, meaning direct to the point. They are not, they are not articulate. Okay, so they are not spontaneous. They go directly to the point. And these are the engineers because they love numbers. Okay, only few engineers can deliver fluently and spontaneously in English or in detailed fashion and in detailed manner. So it's only few. So that's why be careful also during your discussion the using of the English grammar, chemistry grammar, and math grammar as well. Because the grammar is not limited in English, also in technical subjects like science and math. Okay, you get the point. So going back to the discussion. Okay, now if you have the ionization energy here, then we can say that it goes up to your period, and then from left to right also, it will be increasing. The arrow will be like this, going up, going from left to right, increase your ionization energy. And there's a diagonal that will say like this, going to this. The target really is the fluorine. That's the basis, the fluorine. Why? The fluorine is in the first energy level, in the top. And fluorine is the most electronegative of all in the periodic table. Of all 118 elements, the fluorine is the most electronegative element. If the question in the future examination was say, which of the following element in 118 elements is the most electronegative, your answer directly is fluorine. No other. Okay? That's why in our theory, we need to project the arrow going to fluorine in relating the ionization energy, the electron affinity, and also the electronegativity, something like that. And even the reactivity as well. Okay? You get the point. Now, so if we have fluorine, chlorine, bromine, iodine, astatine, right? Atomic mass of fluorine, 19 grams per atom, chlorine 35.5, bromine 79.70, iodine 126.90, and astatine is 210. Okay, you need to memorize the atomic number because you need also to relate the other physical properties. Okay, as your molecular weight will increase also, your atomic size also will be increasing. Okay? Because there's a lot of atoms bonded. Normally, it is bigger. You get the point? So you have to connect that always with the atomic mass. Okay? The size of your element. That's why you can easily arrange if you have the exact atomic mass of each element in your brain cells. Something like that. Talaga brain cells talaga, no? O, di ba? Nakakaloka. Okay? Ganon. So, you have to, actually guys, you don't have to memorize everything, but you have to memorize at least half of it. Okay? Or even a little bit lesser. Okay. For example, me, when I was in college, I memorized 60 out of 110 elements. I memorized all the atomic numbers of these common elements. And then by the time there is a chemical calculation or stoichiometric, I can easily troubleshoot the atomic mass and easy for me to detect the molecular weight because I don't have to look in the book. Okay, so that's the advantage. It can save your time, something like that. You get the point? So it's better, guys, you will memorize whether you are still in high school, okay, in your chemistry subject, or when you are in your first year college, the first 4 semesters of general chemistry lecture. I think you have 4 semesters, including the lab. Okay, chemical lecture 1, chemical lab 1, and then chemical lecture 2, and then chemical lecture, no, chemical general 2 lab. General chemistry lecture 2 lab also. So 4, right? The labs and the lectures. Okay, now, ano siya mahitabo. So with this aros-aros, you can understand and you can compare na talaga siya. Okay, now, ang imong ionization, maurasad siya gapo na sa negativity. Going up, left to right, increasing, and arrow will be going like this. Okay? Ang basically mo, ang basis will be the lighter, the non-metals. Okay? Ganon. Okay. Now, kung ano sa siya guys, what is the most electropositive element in the periodic table? Maglibog na po ka. Electropositive. Okay, how can you do that? Love. How can you do that? The most electropositive metal in the periodic table. Okay. You should not take that literally. Okay? That if we think electropositive that contains more of electrons, it's not like that, or contains most of the protons. The answer will be hydrogen. Okay? Because hydrogen is in the top, in the group 1A. Then take note, the fluorine also is in the top of the group 7A. And there's a charge of valence electrons of negative 7. Okay? Something like that. So opposite ang hydrogen, positive 1. Kay positive man ang iyang charge. Something like, or valence electrons. Okay? Like that. Dili ang helium ha. Okay, edyo katintal sa helium. Kaya ang helium is the second most lightest element siya in periodic table. Okay, and we need helium, helium gas if we go deep underwater by using the scuba. You know the scuba? Okay, self-contained underwater breathing apparatus. This is the definition of scuba. Again, self-contained underwater breathing apparatus. Okay, because we have also SCBA, self-contained breathing apparatus in the land. We use that if you go to inside the confined space. And we have also the opposite in going deep inside the water, the self-contained underwater breathing apparatus or the scuba. That's why we say scuba diving. Okay, and we need helium to survive there underwater. Okay, so that's the element we need during diving, helium. Okay? Don't forget that also, helium. Okay, it will also come out sometimes in the questions in the future. Okay. Ganon. Okay. So, ang imong electronegativity will be like this. Also, tadadat, ganon. Tadadat, and also the electron affinity. Tadadat, tadadat, ganon siya. And the rest will follow na to siya. Imo na diba ng mga tulang uy, so, imo tayo ng molecular compound, and then, ala, ang molecular compound, baya to siya. Ano na yun, di ba? Dali tayo mo masabtan, guys. Okay? Sana, nung dahil nagkuhan ba ng stuck sa inyong brain cells, dali tayo mo masabtan ng uban. Okay? You got the point? Ganon. Okay. Now, ang imong taman aktiman, let's summarize na lang talaga. Okay. You should take note, okay, in our elements. We should take note that, okay, number one, the ionization energy. This is just like a self-review, in preparing of the board examination. It's just like this, but this is not really, specific wise. This is just, picking up topics as long as we can connect the dots. Something like that, okay? So, ionization energy. Okay, mga palangga akong hitad. We have the, affinity. Okay? Electron affinity. Okay? Electron affinity. Okay? We have the electronegativity. Okay? Electronegativity. Okay? We have also the electropositivity. Electropositivity. Okay, mga palangga kung hitad. Now we go to the atomic number. Okay. Atomic number, you can easily associate that with the atomic radii, atomic radius, okay, radii, atomic size, okay, like that. Or shape, atomic size or shape. Okay. For example, if you say, which of the following has a larger atomic shape? So do not take literal because your theory doesn't speak for the shape. Just analyze that the shape, it has to do something with the dimension. So use the theory of radius, radii, atomic size, things like that because sometimes it is not discussed literally. Okay, you have to analyze also, okay? Sa books. Okay, sa books, hindi naman siya specific ka naman naging mo sa book. There are other details that cannot be expounded there. You have to have your own, ano ba, di ba? Kuro-kuro, something like that. As long as it is validated and logical, then bingo, it will be feasible. Okay, feasible. F-E-A-S-I-B-L-E, meaning doable or it can be realized or accomplished. Something like that. Okay? So, atomic shape. Basta shape ganun guys, what comes in your mouth? Ang geometry. Okay, geometry of that shape. Mo na tawag na mga trigonal, tetrahedral, mga ganun siya ha. So, mugin siya mga geometrical shape. Okay, kaya naman natin geometry sa math, di ba? So, geometry under sa algebra, di ba? Natin mo, trigonometry, what is that? Algebra, what else? Solid mensuration, ganon, geometry, under man dito sa mga math. Sa high school? Okay, sa high school siya, di ba? Meron na nga. Okay, something like that. So number 6, we have, ganon guys, no? We have the melting point, boiling point, freezing point, ganon, and also density and solubility. Okay, like that. Okay. I mean, solubility of density, guys, normally, guys, okay, sa libro, density and solubility, if you try to be bookish, this will not be connected to the periodic trends. Since I have the opportunity to discuss with you, this can be connected also here. Because the solubility, it has to do something how lighter and weight the object is. Now, if it has to do something how lighter and how heavy weight the element is, it has to do something with the atomic masses. Right? So you can see also which of the following has higher density. Fluorine, chlorine, bromine, iodine. Even though it is not discussed very well in your classroom instruction, having that theory in your brain cells, that as long as the molecular weight is very high, it's understood to be heavy. Normally, common sense. So if it is heavy, then the density is very high as well. You get the point? Because density is equal to mass over volume. You get the point? If you take volume as constant, trying to have constant volume to be considered, then the masses will vary. And the masses will focus on your molecular mass. So that's why you need to associate the density in your molecular weight. Though it is not explained clearly also in different reviews that I taught in my college days, it's not mentioned also. This is only by myself. Okay, I'm connecting the dots. Okay, something like that. You get the point? And then solubility also will matter a lot. Though solubility is also connected there, but you need to think also things like that. If that is solubility, meaning it is softer, because it will be easily to be
dissolve. So if it is easily to be dissolved also, then it is lighter. You get the point? Because how can it be dissolved easily if it's too heavy? Something like that. So the molecular movement, the molecules will not be, easily to be dissolved or to be dispersed if it is too heavy or a lot of molecular movement, things like that. So, maliliit siya po mo ang solubility. So, meaning to say, it's very, very difficult to dissolve if the molecular weight is also high. You got the point? Or if it is having a high density, because it's connected also with solubility. Because solubility, it has to do something also with the density. Okay? You get the point? And it's directly proportional to each other. Okay? Though the periodic trends are not including these two, the density and solubility, I have to add to expand on our theories and concepts about this. Okay? Now, melting point benefit is very easy, right? Okay, number 7. What else? The reactivity. Okay. This reactivity, guys, is confusing also. Okay. Why? Because we have also instability and stability. Okay. So, in our hazardous materials or chemicals sold all over the world, okay, it's not expressed in reactivity sometimes in the packaging. Okay? And you don't have to be literal. So that reactivity is the same as, okay, instability. Because the more it is unstable, the more it will react to other substances. In short, instability and reactivity is connected with each other. Or else, if it is stable, it will never react. You get the point? Or that is inert. Or that is noble. Like that. When you say noble, inert meaning stable already. I will never longer to associate with others because I'm already stable. So meaning I am unreactive. Something like that. But here talking about reactivity, so instability, not stability. You get the point? And instability is part also of the 16 sections of our safety data sheets. Okay, all the chemicals that we have. For example, if I try to purchase chemicals, if I want to study and experiment, for example, hydrogen peroxide, like this, if I have my scientific research study, like that, thesis, something like that, okay, we need to understand also this theory, okay, instability and stability, like that. Okay, there will be a lot there. I think 16, including the, reactivity, flammability, okay, the first aid measures, the firefighting measures, okay, the ingredients and compositions, and the product name, okay, the trade name, like that, the toxicological information, the ecological information, okay, get the point, and the spill energy response. If there are spillages and leakages of the chemicals, then you have to correct it immediately because to avoid fire and explosion within the vessel or in the vicinity being considered in your process. Something like that. And you have to be extra careful also for each section of the 16 points of your safety data sheets. That's why we need to have cost for that. Okay? Of Control of substances hazardous to health. That is cost. If you have the safety data sheets, you have also your corresponding cost for that. Okay, and it's requirement in OSH. Okay, going back to number 7, reactivity. Okay, that's the area where I shifted my profession because of this chemical, aspects of OSH. Okay, something like that. If there are chemical hazards, there's also biological hazards, and we can easily correlate that because we know the properties of chemicals. And if you study a lot of, the characteristics of substances, we corresponds to the biological hazards as well. Okay, ganon. That's why most of the chemical engineers nowadays are taking OSH as a career path, transition. Okay, like that. You get the point. Ganon. In fact, my guys, the commissioner also of chemical engineers is a safety engineer. Okay? Ma'am Shiril in the Region 7, something like that. She is safety engineer before in California Energy, geothermal power plant. Okay? So, at the time, I know her already. She is a safety engineer. And now she is the commissioner of the chemical engineering, discipline nationwide. Something like that. See? So, take up also OSH. Kay related na kayo ang OSH sa chemical engineers, guys. Okay? Something like that. Okay. Muna na siya, guys. So, 7 lang yung kabuk ako ng mga kapatid, ha? Okay. Muna siya may tabo. Gamit po rin siya, guys, sa mga kuwan. Polymer engineering and petroleum engineering. Okay? And also nuclear engineering. Okay? Subdivision of chemical engineering, highly specialized, components of this chemical engineering, but more highly demand, okay, nowadays. The petroleum engineering and the nuclear engineering, okay, something like that. And even the forensic, forensic science engineering, because used in the criminal study, who killed this person, and we need to analyze the DNA of this person through the urine, through the blood sample. Then, of course, you know how to compute the stoichiometric relationship of those substances. So being a chemical engineer, we can easily do that because we know exactly what is the formula of urine. Okay, what is the chemical formula of the blood? Something like the hemoglobin, the RCBC, right? No, not all chemical engineers, but most will know that. Okay, something like that. Because naman sa mga chemical engineers na pabaya lang siya, stagnant siya after graduation. Okay, because if they work in their field that doesn't connect to chemistry, to physics, and then they stop loving science also when they do the actual work in the future, something like that. Okay, so that's why I told them it's never ending. The learning is never ending. It's a continuous process, something like that. Okay, it's not a sleeping child. It's a dynamic child. Charot lang. Okay, ganon. Any questions so far mga palangga kong hitad? No more questions? So that mag-proceed na ako sa akong removal examination. Removal examination in University of Harvard University. Charot! Okay, bye-bye. God bless everybody. If you try to comment in the comment section, then you can do that also. And then you can also like and share this to anybody else. And then you can also subscribe to my channel if you want also. Uy, mga palangga, di malingan. Pero ba ko ganina? Okay, about, basta. YT wants us to talk about katungkuan ba? Ukraine and Russia. This thing there, don't talk about Ukraine versus Russia. And if you talk about that, then you will be terminated in the YT channel because it's highly sensitive. Oh my gosh, why like this? Okay, thank you so much. Bye bye. God bless everybody.